Assalamualaikum and good morning to everyone. My name is Muhammad Azhar Muhammad Farid with the ID number of 92110307 5475001. In this module, Maintenance Management, I will explain the maintenance strategy in the global context. And the company I will explain is surely Places Manufacturing Sdn Bhd. Throughout my working experience since 2014 until now, a lot of information and the up and down situation have been shared with us. Places Manufacturing has been partnering with companies around the world to transform their concepts into branded products and deliver them to the market. With the global force of over 19,000 team members who draw inspiration from solving the most complex product challenges, at Plexus, they are dedicated to provide the seamless product realization experience with customer service which had never been seen in the electronic manufacturing industry. Evolutions in additive manufacturing, automation and industrial robotics are changing every step in the manufacturing process. Manufacturers are adapting robotics and technologies to collaborate with human engineers and also operators, which freeing them up for higher level tasks and thereby increasing overall efficiency. At Plexus, they make use of various advanced manufacturing and industrial automation technologies, allowing them to provide cost-efficient, high-quality products with extremely quick turnarounds. Plexus Manufacturing Sdn Bhd offers technological solutions for electronic manufacturing industries. The company provides solutions including mechanical, electronic, and software design, printed circuit board development, prototyping services, new product introduction, material procurement and supply chain management for communications, medical, security, aerospace industries worldwide. Plexus Corporation refers to itself as a product realization service, which helps to corporations design and develop and manufacture electronic components and other products. The company is organized into two operating units, which are Plexus Technology Group and Plexus Electronic Assembly. The Technology Group provides product development engineering, prototyping and test development services. Electronic Assembly provides manufacturing and aftermarket support services. Plexus has three types of facilities that are used in the product realization process, which are design centers, proto centers, and also the manufacturing centers. The company was founded in 1996 and based in Bayan Lepas, Penang, Malaysia. In Penang, Plexus manufacturing first plant is the Hillside plant. Then the second one is the Seaside plant. Third one is the Riverside plant. The fourth one is the Island View plant. And the newest and be the fifth plant is the Riverside East, which is new 432,000 square foot manufacturing facilities, which were completed on the 1st May of 2018. Plexus offers many exciting opportunities for the 19,000 employees to collaborate with global teams across the company. They have an innovative culture built around problem solving and offer their employees the opportunity to discover their potential by partnering with leading companies to bring exciting, life-changing products to reality. Let's see the organizational chart of Plexus Manufacturing Global Team. Okay, maintenance strategies. A maintenance strategy is a systematic approach that companies use to maintain their assets in prime working condition. It involves maintenance checks, data analysis, for example, KPIs and metrics, failure rates, performance, and costs, and the repair or replacement of faulty equipment. A high-level manufacturing plant maintenance programs typically mix several different maintenance strategies based on the needs of individual equipment. An effective maintenance strategy consists of it can reduce the downtime and guarantees the high quality equipment availability. Second one is the keeps maintenance and operational costs low and predictable. It can optimize facility performance and production line processes. It maintains a high level of safety, improve customer satisfaction, and also extend the equipment life. To choose the right maintenance strategy, you will need to assess existing organizational data such as asset performance, maintenance costs, and failure rates. Once we have the big picture of our organization's current maintenance and operational structure, it is recommended to review the types of maintenance strategies before conducting a criticality analysis. There are types of maintenance strategies in the context of manufacturing. First one is the reactive maintenance, which brings the meaning is when it breaks, we need to fix it. Second one is the preventive maintenance, which is a scheduled replacement ahead of time before parts breaks, usually at a regular interval. Next is the usage-based maintenance, which is to replace parts when the machine has been used by a certain amount before they break. Next is the condition-based maintenance, which is replace the parts when they seem like they are getting too worn out to continue to function appropriately. Next is the predictive maintenance, which is utilize historical data to make prediction about when a part will break and replace the part based on these predictions prior to them breaking. This usually but not always utilize artificial intelligence and machine learning. Next is the prescriptive maintenance, which is the advanced data analysis method I use to do more than predict the failure points, but instead provides hypothetical outcomes in order to choose the best action that can be taken prior to the failure. Safety hazard and quality issues arise, as well as the timing of implementation. In the last few decades, manufacturing organizations were forced to shift their business models from closed system orientation to more open system orientation. This shift was brought about by drastic competitive force, which made the customer the focus of organizational, operational, and strategic practices. Today's manufacturing organizations are required to operate as open operational system. In such system, advanced operational manufacturing technologies are blended with modern information and communication technologies to integrate and coordinate operational resources, processes, and activities in order to generate a stream of value-added operation which will aim at capturing and sustaining a competitive advantage. With the increasing complexity, scope, and organization role of operational advanced manufacturing technologies, the maintenance of these technologies is becoming very critical to the ability of the organization to compete. In this context, operation management, especially maintenance management, is taking on a broader organizational strategic role. Traditionally, maintenance with its multifaceted activities, resources, measurement and management has been important to manufacturing organizations. However, in recent years, the need to manage the different facets of maintenance more effectively has gained added importance due to the changing operational technologies and the changing organizational role of maintenance. In today's open system manufacturing organizations, maintenance has a broader perspective. In such organization, the scope of maintenance has shifted from a narrowly defined operational perspective to an organizational strategic perspective. In such operational environment, the role of the maintenance manager is critical. Therefore, the need for these managers to receive appropriate formal educational training, which incorporate the different facets of their increasing organizational roles, is becoming more important than ever before. Motivated by the increasing significance of the different facets of maintenance management in today's open system manufacturing organization, this literature review focuses on performance measures, measurement and management of the different aspects of maintenance. For the purpose of this literature review, several electronic databases were utilized. In the process, articles published in the last 30 years are identified, analyzed, and classified. This research effort facilitates tracing the evolutions of performance measured and measurement as related to the important maintenance organizational function and its resources, activities, and practices. As a result of the detailed examination, directions for future research are identified and articulated. In manufacturing organization, maintenance-related costs are estimated to be 25% of the overall operating costs, according to Cross in 1988 and also the Commandant on 2002. In some four industries, such as petrochemical, electrical power, and mining, maintenance-related costs may surpass the operational costs, according to Rauf on 1993. As such, close attention should be paid to maintenance, performance, measurement and management in order to utilize the scarce maintenance resources more effectively and, in the process, improve overall organizational efficiency and effectiveness. In order to utilize maintenance, performance, measurement, and management to promote positive and proactive organizational change, the maintenance performance management system should be designed to track and improve the different aspects of the maintenance effort. Despite the overwhelming benefits gained through effective performance measurement and management, and the fact that organizations using integrated balanced performance management system tend to outperform their counterparts which do not. Studies have shown that 70% of all those systems implementation initiatives have failed. Even worse, in a survey of manufacturing organizations which were conducted by Cholosuke on 2004, only one of the third of the organization with good maintenance management practices tended to realize the full benefits of their maintenance management initiative. This led some researchers to advocate the utilization of broader and innovative performance management approaches such as the balanced scorecard and new organizational improvement instrument. Overall, effective performance measurement approach can play an important role on a particular aspect of organizational tasks. According to Parida and Kumar on 2006, the following are considered important factors justifying the implementation of a maintenance performance measurement process, which is measuring value created by the maintenance, justifying investment, revising resource allocations, health, safety and environment issues, focus on knowledge management, adapting to new trends in operation and maintenance strategy, organizational structural changes. As a result of a focused literature review, 345 different measures emerged with a total of 696 occurrences. The main 37 measured with more than 2 occurrences. It is to be noted that costs with 55 occurrences was the most used maintenance performance measured as approximately around 50% of total occurrence within this group of measure. The most utilized measure represented several dimensions of maintenance performance, namely technical, economic, safety, and human resources. The least utilized measure group included several measures such as training, skills, work incentive, process performance, resources utilization, maintenance capacity, customer satisfaction, and also the employee satisfaction. While cost is an important measure, future research should also focus on deriving practical performance measure which will aim at capturing the human factor of the maintenance performance effort. In this context, the automotive, electrical, and electronic, and also chemical were the most represented industries. Future research should attempt to integrate the findings from the case studies into practical implementation methodologies. The characteristics of the industry should be examined in attempt to conceptualize industry-specific factors in relation to effective maintenance performance. Therefore, it is fundamental for maintenance managers to be aware of the organizational business strategy. As they manage their maintenance resources, the business strategy should drive the selected maintenance approach, models, and strategies utilized. For instance, a just-in-time operational approach requires high machine availability. Therefore, such operational environment should stress the importance of preventive maintenance. On the other hand, total quality management, which is TQM, requires machines to be in excellent working condition. Therefore, scheduled maintenance is needed to promote and support a TQM C1 operational orientation. Overall, it is important to have an organizational systematic maintenance strategy to guide the strategy use of maintenance resources, models, and techniques. There are many models, techniques, and systems and approaches available to facilitate and support maintenance management of activities, resources, and decisions. In this context, several new approaches and strategies can be utilized. These include, among others, self-maintenance, a web-based maintenance, integration of product and maintenance design, proactive maintenance based on intelligent units, life cycle simulation for maintenance strategy planning, model-based maintenance, total productive maintenance, which is TPM, reliability-centered maintenance, RCM, preventive maintenance, which is PM, a condition-based maintenance, CBM, and also the continuous maintenance, which is CM. Therefore, approaching maintenance management strategically and systematically has become essential to make the right choices, especially in capital-intensive industries. The literature points to strong linkage between business strategy and manufacturing maintenance strategies. As such, there is a need for a well-designed and implemented organizational system to manage maintenance and related performance aspects from a strategic perspective. According to Alisoff on 2006, such systems should have the following characteristics and abilities, which is assess the contribution of the maintenance function to the strategic business objective. Next is the identify the weaknesses and strengths of the implemented maintenance strategy. Third one is to establish a sound foundation for a comprehensive maintenance improvement strategy using quantitative and qualitative data. Next is the re-evaluate benchmarking maintenance practice and performance with the best practice within and outside the same industry. Next is the track maintenance impact and showing the linkage between operational and financial measured holistically. As the conclusions, today's open system manufacturing organizations tend to view maintenance as a strategic competitive resources. This view is consistent with the maintenance performance measured, used, and the information system utilized to gather data. These manufacturing organizations tend to view the maintenance effort as integrated strategic organizational system. In the process, these organizations tend to approach needed information based on an integrated database informational perspective. This organizational informational approach is supplemented through the effective utilization of broader benchmarking practices. In this context, organizational performance focus is on operational, strategic, and value-added objective and also the goals. The operational technologies used in this organization are based on the automation and integration of different operational capabilities. From an implementation perspective, manufacturing organizations are in need of systematic, dynamic performance management approaches. Such approach should be able to measure, monitor, track, and continuously improve the different aspects of organizational performance. In this context, it is critical for these organizations to integrate their maintenance-related performance aspect into the overall organization performance systematic approach. As organizations attempt to implement such organization performance improvement approaches, they must understand the relevant performance issues and concern related to the growing organizational role of maintenance effort. That's all. Thank you.